It's a lot of red. It's a lot of red. Ah, pizza. Oh.
Hello everyone, can you hear me? Just doing some quick check of the hardware here. Awesome. We'll start in just a few minutes at noon Stockholm time. I'll be talking to you soon. Sushi Commander, to answer your question, no, it was not necessary to watch part two. Those are fairly independent. It's a lesson for me in the future not to number them probably and just give them names. But if you just join today, it's not going to be a problem at all. Will there be more like For the Jurassic, we have one more planned after this one. So that will wrap up the Jurassic. As for later, we'll see. I have only started sorting the material for the Cretaceous, so I'm not quite ready, far away from being ready actually with it. But maybe after New Year's, we'll see. We'll see how things go. Okay, folks, let me do a quick test to see if the presentation is displaying correctly while we wait for everyone to join. Yes, I can see the slides changing. All right. Can everyone see my mouse pointer? It's flying around the place. Hey, Penny, thank you so much. Okay, looks like everything is ready to roll. We have 2 minutes to start. We'll see how many people come today. I only realized today that we are competing with another major event today happening in the United States where two dinosaurs go head to head for domination. So we'll see if that encourages more people to join or if just like me, people like watching what is happening there and might skip it. Okay, my clock is showing noon, so I guess it is time to start. Welcome back to the Jurassic, everyone. If by any chance you are joining us for the first time, don't worry. Even though this is part three, those are fairly independent, so you don't need the knowledge of the previous streams to get into this one. What we'll be talking about today is still the Upper Jurassic period. We started going into it in the previous stream, but today we'll be focusing on a different slice of time. That is the Kimmeridgian period. And when you look at it, you might wonder, this is a pretty short slice of time, just 5 million years compared to some of the other streams we did. And it is true, it is pretty short, but a lot is happening. And the reason why we have a lot to talk about is the Morrison Formation. This is a geological formation in the United States. And what it is a very fossil rich area that was likely in the past a site of a massive landslide. This was a watering hole, probably a river or some kind of lake that dinosaurs and other animals congregated around to have a drink, and there was a massive landslide that buried there. So this is just a probably number one place for bones in all of Jurassic, really, not just the late Jurassic. And the only side effect of that is that today's stream will have a big I suppose thematically, big North American theme to it. Most of the dinosaurs we'll be talking about today have been found in the Morrison Formation in the United States. Another thing that this deposit is great for are the really big dinosaurs. There are a lot of sauropod bones we get from there, which is why I named today's episode Giants, because we'll be talking about what is arguably the peak of diversity for those giant long-necked animals. And in fact, the first half of today's stream will be mostly about them. And later in the second half, we'll talk about some other things. So, without further ado, let's get started with one sauropod that is probably the most famous, I would argue, probably next to Diplodocus or maybe Brontosaurus. So Brachiosaurus, you know probably pretty well from the Jurassic Park series. You can note this very unique pose, very long front limbs and a vertical neck going pretty high. The animal is pretty sizable. Here you can see an average size reconstruction based on bones from various specimens next to a person there under the tail. So this is one of the pretty big ones already. And in fact, they didn't stop growing at this time yet. They will only keep getting bigger. So Brachiosaurus was featured in Jurassic Park in the whole series, but this is the first slice of the material that we got of it. And it's actually fairly accurate. They didn't actually use Brachiosaurus, as it turns out, to reconstruct this animal. They used a different sauropod. We will talk about it in 2 weeks. So just FYI, the Brachiosaurus in Jurassic Park is actually bigger than the actual Brachiosaurus, and it's a different animal. But as far as anatomy, basic anatomy, size aside, it's pretty close. What they didn't get correctly were maybe a small detail, but the nostrils. So Jurassic Park and many pop culture materials reconstruct Brachiosaurus with nostrils at the top of this crest, at its forehead. In fact, the nostrils were not there. You can see at the bottom and the right pictures something that was more accurate. The crest also looked a little differently. So this is a small detail that should be noted. And there is also a possibility that the animal had a little more flair to it, I suppose. Since dinosaurs are related to birds, it is possible that some sauropods also had some quills or feather-like structures on their bodies. Those features are speculative, though, just FYI. By the way, what you are looking at here is likely how the Morrison Formation looked like before this whole landslide came in and buried all those dinosaurs underneath it. So it was a really big area. Here are more conservative depictions of Brachiosaurus, so you don't see those feathers, just a basic skin, maybe a little bit of quills. Again, nostrils are not accurate on the one on the right, but you know this already. Size-wise, I think this is a good picture. You can see here a person next to a humerus, not femur. Basically one bone the size of a human being. I want to show you just a few more pictures of it. Here is how it could have possibly propped itself up to reach up to higher branches, standing on 2 legs. And here is a cuter reconstruction, but showing it with a juvenile walking alongside it, because of course not all Brachiosaurus were adults and fully grown. Another thing I want to show you is this small clip from Jurassic Park. There is a reason why it's on the left. I will explain in a moment. I want you to take a look at it. It's very short. And after it's done, tell me what you think is wrong with it. So we are looking for a mistake.
Looks like it has a cold.
Yeah, maybe.
Can I touch it?
Sure. Just think of it as kind of a big cow.
I like cows.
Okay. Which streamer? Damn, you got it on the first go. Yep, you are correct. It is the fact that it's chewing. They didn't chew. What we are going to talk about next is the sauropod feeding habits. So many of you probably heard about the fact that dinosaurs swallowed rocks and stones to help with their digestion. It is true, they did it. And the reason why is this. So they were huge animals and they had really high energy requirements. So they had to eat a lot of food, a lot of material. And chewing, believe it or not, is a waste of time. If chewing might help you pre-digest essentially the food or make it easier for digestion, but it means when you chew, you are not biting, so you are eating less material. So sauropods, in order to eat enough food to support this body mass and to sustain their energy requirements, they didn't chew their food. They only ripped it off and swallowed it. And the rocks they swallowed when they were drinking from a river, for example, helped break down the food in their stomachs and help them digest it. Another thing you see here on the right, this chart, it shows that they didn't move around much. So they had this neck that had a very wide range of movement. What we are looking at here is not specifically Brachiosaurus neck. This is, I think, Diplodocus. But moving around would also have been an energy expense, also not something efficient. When you are this massive, you want to be as efficient as possible. So they would stand in one place and just move their neck around the place, eating food, ripping it off the branches, and after they have cleared the immediate area around them, they would relocate to a new place and begin the process. So this is how they ate. But there's more to talk about when it comes to sauropods. And first question that probably a lot of us have is, why did they get so big? And there are a few reasons for that. So first, there's always some sort of competition in the environment. Theropods, so those predatory dinosaurs, started growing in the Jurassic. So one of the possible adaptations for animals that are prey is, of course, to grow as well. So size of an adult specimen would have made it probably immune to most predation in the environment unless they got sickly. Another reason is a new niche to fill. What you should know about late Jurassic and the Cretaceous is that the plant life got really big at this point. It wasn't maybe as widely spread as it was, for example, during the Carboniferous, but this is when we get the sequoia trees, so redwoods, so those tallest trees out there, and really tall plant life. So there is a new niche, tall plants, so obviously some kind of animal will emerge to utilize it, and so dinosaurs did. Another reason are their bones. And what you're looking at here is a model of a dinosaur bone. What you will note is that there is a lot of empty space inside. So those empty spaces, they do two things. First, they make it lighter, and second, believe it or not, they make it more sturdy. So even though our bones are fully filled, because they are heavier, they actually need to lift more weight. And it is more efficient for a bone to actually have some empty space inside it. This is kind of like, you probably hear about nanotubes or carbon being used for super light structures. This is a similar idea. The way those structures inside the bones are located makes the bone actually lighter and capable of lifting more weight than it would if it was fully filled inside. Another thing that hollowed out bones allow is the additional presence of air sacs. Air sacs are one of the things that help decrease the total mass of the animal and help it lift up this huge, many tons heavy body. So all those two things together come, when you sum them up, even though the animals were big and they weighed long, relatively to their body size, the mass was actually lower than what you would get from an elephant. So dinosaurs were actually more efficient in growing than mammals would be later. And finally, there is one more reason, which is they were laying eggs. And this might be a little weird, but one of the reasons why mammals can't get this big is because at least most of the mammals, gestate their babies inside their bodies, and the babies grow for a long time. Like the elephant pregnancy gets way over 1 year long, I think about close to 2 years if I remember correctly. So if you wanted to get even bigger, you would need to wait longer, and the longer the pregnancy, the higher the risk there is for the mother and the fetus, of course. So laying eggs actually means that you can reproduce babies that would eventually grow bigger, because a big part of the gestation takes part in the egg, not inside the animal itself. So multiple reasons why they got so big. Now, even though some were very big, mostly brachiosaurs, there were actually some that were relatively small. So Europasaurus is an example of a brachiosaur that quote unquote suffers from insular dwarfism. So it was an animal living in an island environment in Europe, in Germany, I believe. And it was actually the smallest brachiosaur that we know about, so up to 4 meters tall. It's actually gotten quite famous in some circles. Here you can see where it lived. This is Europe in the late Jurassic, so a huge archipelago, a lot of island environments, and brachiosaurs and the different brachiosaur species which got isolated there later evolved into forms and body sizes that would have been easier to support in an island environment. So not all sauropods were huge. Europasaurus has some neat art going forward. This is an older piece in which is what I think is supposed to be Solnhofen of the Jurassic. Here it is shown wading through water, moving between the islands of the European archipelago in the late Jurassic. Here are just two of them just chilling. And of course it has some fan art, extinct no more. I wish that was true, but unfortunately not so. And Europasaurus is actually going to get a graphic novel, which is a thing, and I'm really looking forward to it because art from it is already pretty nice. Here you can see some adults and a baby in the background looking at a mammal in what is a hollowed out trunk. But those were brachiosaurs, but there are other forms of sauropods out there. So one of them is Gallimiopus, and what Gallimiopus is a diplodocyan. So what you can see already is that the body shape is very different. It is not a tall animal. It is long, very long tail, more of flatter head without the crest. It's actually the back legs that are longer and more muscular than the front limbs. So it is looking a little different, and it will in fact fill a different niche. What is very characteristic for diplodocids are those very long tails. We'll be talking about them in more detail in a moment. What I want to do now is go back to this tree. You saw it in slices and bits and pieces previously. Just a quick update. Diplodocids are here. Brachiosaurids are, of course, here. This is where the Brachiosaurus lays. Now, most of the stuff here on the left, those two-legged sauropods, are extinct at this point. There are no more two-legged sauropods in the late Jurassic. So, going forward, to give you a better idea of how this whole family tree looks like, we will simplify it a little bit and expand it to the right. So, we will be looking at only the sauropods that are alive in the late Jurassic and going forward. So, when you zoom in into this tree a little bit, you can see that diplodocids have this separate branch. There are actually two kinds of them. We'll talk about the other in a moment. And brachiosaurs are in the titanosauriforms, and there's this whole big branch going here that we won't be talking about in the Jurassic, but in the Cretaceous. Now, let's talk about the big daddy of the diplodocids, so Diplodocus, one of the most famous animals here probably. Hello, elf strategist. It is all cool. And again, I think I want you to pay attention to is the tail, the super long tail. Here you see the size, so about 30 meters long. So lengthwise, this is actually about the size of a blue whale. Of course, it's a less massive animal, Diplodocus, because as you know already, they were lighter compared to mammals. And second, of course, the tail is a big part of it, and so is the neck, so they are less massive than the whale itself. Now, I want to talk about the tail a little bit. I will mark it in the red here for you, so you can see how long this thing actually was. It was a massive freaking tail on a really big animal. And this tail, it actually deserves a bit of a closer look. So, first of all, it was double the length in terms of the number of vertebrae, so number of bones, right? It was double the length of other dinosaur tails. So this was a very unique adaptation to diplodocids only. Brachiosaurs didn't have tails this long. What it likely served was a counterbalance for this long vertical neck, because the neck was vertical, unlike with brachiosaurs, which had it horizontal. And even if they wanted to lift it or move it around, they used the tails to provide a counterbalance and not flip over, because this is a lot of mass on both sides of the body. Second, it was probably a weapon. So there was some research done to see if the tail could have been used as a whip. Would have had a massive crushing power. You would not want to get slapped with that thing. And because it was so long, some scientists also speculate it also could have been used for communication in two ways. One, it could have been colorful, so it could have been lifted above the head just to signal to other members of the herd, hey, here I am. And second, because it probably cracked like a whip, could have been actually a sound essentially that they were using to communicate by cracking it in the air and letting other animals know that they are close. Finally, it was probably used as a herding tool. You might remember me talking earlier today that brachiosaurs were all about energy efficiency, and when you are moving as a herd, you don't want to stop and turn around and look around and see if your herd members are still here. What you do instead is you walk relatively closely and you use the tail to gently flick the other herd members that are walking beside you or behind you. So this constant need for physical contact is why we have not found a Swedish or Nordic diplodocid yet. So we'll see if there will be a first, but none so far. Now, I want to show you a short video, unfortunately without sound, which annoys me a little bit, so I will narrate it a little bit for you. And this video shows essentially a model of a sauropod tail constructed by scientists that was created to test the hypothesis, difficult word, about whether they would have been able to crack the tail like a whip. So I'll skip through the video to the interesting bit. Here it is. So you can see a guy has this tail, right, constructed on this mounted item, and he's moving it around the way the animal could have, probably to see if it can crack the sound. And the speed of the sound is 340 meters per second at sea level. So we'll watch a zoom onto the crack of the whip now to see how fast the tip of the tail could have gone when it was being used as a weapon or a communication tool. So pay attention here. When it's expanding and it's changing the direction, this will be the critical moment, and you will see an overlay with the tail speeds in a second. So the ones in the purple, you see, this is where it goes supersonic. So it moves faster than the speed of sound, this tip of the tail. And this is how the whips work. When the tip of the whip moves faster than sound, this is when you get this audible crack. So it would have been probably pretty loud, and getting hit with that thing, it would have hurt like hell, and they would have probably been able to break animal bones using it. So this is pretty freaking awesome. So moving on, a few pictures of the Diplodocus. You can see here a full body shot. Some kind of speculative spikes on the tail. We don't know if it actually had them or not. Here are two of them just chilling in the undergrowth of a massive forest. Here's one with some speculative crests on its head and neck, chilling on the coast. This is a very old reconstruction, but not entirely inaccurate. You can still have this. You still have this very long tail and a vertical body. Dark asks, how didn't they break their tail doing that? Well, I'm not adept at the anatomy of them. I imagine the musculature in the tail was enough to keep it from happening, right? Some more pictures, just them chilling at the side of a lake, moving through a forest. Here are more of them. On the left, you can see, because again, the back legs were stronger than the front limbs, they could have probably propped themselves up pretty efficiently on those hind limbs. And finally, a Diplodocus baby just eating some ground level vegetation. And one chilling on the coast. Here, one getting a scratch of a tree. And of course, some diplodocids walking next to a sandworm. Like after hearing how deadly that tail could have been, I'm not surprised that sandworms went extinct. A real shame though. And finally, my favorite picture, not showing the whole animal, but just how big it would have been, some pterosaurs flying next to it. So I want to stop for a moment because Dark Lord actually asked an interesting question. So he's asking what Diplodocus steak would have tasted like. And there is actually, we can actually deduce that. And the question is, would have they tasted like chicken? So depending on how big the animal is and how much musculature it has, you can determine whether the meat would have been red or white, and how dynamic it was. So theropod dinosaurs, so two-legged dinosaurs, would have probably had more white meat, so their taste would have probably been closer to chicken. But sauropods, they were massive. You would probably get red meat, and they would have probably tasted closer to a beef or major herbivorous animals that we tend to eat nowadays. So this was a good question. There is actually an answer to it, as you can see. Now, I want to talk about some other sauropods. You can see an arrow here pointing at the base of this tree, Neosauropoda. This is actually one of my favorite sauropods. It is a little funky, Camarasaurus. It is a medium-sized animal, as you can see here. I really like it because it has this short snout. It looks a little bit like a bulldog. It is, I think, really cute in some ways, looking a little odd and a little weird, but I really like it personally. You can see a few pictures of it here. Camarasaurus in the front and bigger sauropods in the back. Here are two of them. Maybe this is how they would have fought like. And on the right, bird's eye or pterosaur eye view on a herd of them moving along. And this is one of my favorite pictures of them. You can see baby Camarasaurus swimming away, which, yes, sauropods would have been able to swim. With this mass, you have a lot of buoyancy, and this body shape would have allowed them to float in the water, at least for short distances. And here's one chilling in the mud, and some speculative nasal features like inflatable sacs. We don't know if they were actually there. So yeah, and here are two just chilling in the sun. So Jackdaw asks, why are the front limbs elephant-like and back legs with fingers and claws? This actually depends on the kind of sauropod you are talking about. What we need to remember is that sauropods evolved from what were initially two-legged dinosaurs that looked more like theropods that you see T-Rex. T-Rex is a theropod. So they were actually losing those claws as they were growing. And the claws, the reason why they retained them, especially in the front limbs, because most of them will actually be in the front limbs, was probably because they could have made it a little easier to hook themselves on a tree trunk and prop themselves up and reach even higher with their neck. Now, I want us to go back to the diplodocids. So you saw Diplodocus. Diplodocus is a part of the Diplodocinae family. But there's this other one, the Apatosaurine. And those are pretty interesting because you've probably heard about them, Apatosaurus and Brontosaurus. And what is different about them is, especially when looking at the picture on the left, they have a similar body shape to a Diplodocus, but it is a little less elegant, I would say. They are chunkier, much more massive necks, really thick compared to a Diplodocus. We'll talk about the role of this neck in a moment, but first, I want to talk about history instead of prehistory for a moment, because you can't talk about the Brontosaurus without talking about the bone wars. And the bone wars were a competition between those two gentlemen. They were paleontologists who were one of the earlier ones, and this was in the time when a paleontologist was like a rock star, so there was a lot of money and a lot of fame in it. And Cope and Marsh were actually friends initially. The thing that happened was that Cope invited Marsh to explore his quarry that he bought in order to dig up some bones, and there were some really fucking awesome bones there. So Marsh, of course, he loved his friend, but he liked the dinosaur bones more. So what he did was he paid the quarry master to actually send the bones to him instead of Cope, and this started a bitter rivalry between them. So they started digging up lots of bones. They weren't paying lots of attention to what kind of animal they were actually digging. It was a race for how many bones you find, how many new animals you name, and how much money you make. And they would sabotage them themselves. They would pay people off to sabotage their operations. It's a long story that deserves a presentation of its own, maybe one day. What I want to talk about is that first, Marsh discovered an animal called the Apatosaurus ajax. So one of the Apatosaurinae, and the animal after which this group of sauropods was named after. Later, he also found Brontosaurus excelsus, but not really. So the thing with Brontosaurus is that After some examination, a few decades later, paleontologists determined that Brontosaurus was not actually a separate animal, that it was actually just an Apatosaurus also. So, in fact, this was still just one species, or at least one genus of Apatosaurus with a multiple Apatosaurus species. So, but that didn't stop the pop culture, because Brontosaurus was such a charismatic animal that the museums and pop culture went for like 90 years just pushing Brontosaurus everywhere. So even though the animal wasn't real, in pop culture it became super abundant, and it took until 1990s for the rest of the world to get a message and realize that Brontosaurus is not actually a thing. But in 2015, this guy, Emmanuel Chop, led a study of sauropod remains. So they gathered lots of bones from across the world and re-examined them. And what they discovered was that no, actually, the animal that Marsh found, that he named Brontosaurus excelsus, was a different species after all. It was not an Apatosaurus. So they reclassified Brontosaurus. So Brontosaurus was back, and after analyzing Apatosaurinae bones across the world, determined that there were actually two more Bronto species. So, in all fairness, this discussion is still ongoing. They seem to have some pretty strong arguments for it, but it turns out that after what is, well, over 100 years, Brontosaurus is back. So we have both, both the Brontosaurus and Apatosaurus in the media, and with that in mind, we can talk about both of them. Here is a better look at Apatosaurus. Like I told you, really massive neck. You can see lots of this meat and mass dripping down from it here in this picture. I really love this one. Size-wise, not as big as Diplodocus, at least not as long, but the center of the body and the neck were really much more massive. Here are a few more pictures of it. Some a little exaggerated and a bit cartoonish, of course, but overall what you need to get from this is that Apatosaurians were those a little more chunky diplodocids with especially pronounced thick necks. And Apatosaurus was actually featured in the Jurassic World, not maybe in the most flattering fashion. There was a herd of Apatosaurs that were devastated by Indominus Rex. Now, Brontosaurus, this is probably the more famous one. It actually got lots of drawing back in the day. This piece of art actually shows it in one of the old depictions when the scientists still thought that sauropods were so heavy they couldn't walk on ground. They would need marshes to live in the water, an idea that was disproved since then. This is a more up-to-date, even if not necessarily anatomically accurate reconstruction of the Brontosaurus after its reclassification as a true animal, and something that is more accurate in regards to how the animal would have looked like. A few more pictures. Lots of them in the shadow because people were uncertain whether it was a real animal or not. Over the time, not a lot of good Brontosaurus are to be found. But what is interesting about Brontosaurus also is that their necks had those weird vertebrae that were extending pieces of bone. And one of the ideas is that there were actually pieces of bone or cartilage emerging from those massive necks, and they would have been used for really bloody fights between the animals. The paleontologists have a name for this fight called the Bronto Smash, and there are a few pieces of art that depict it. You can see those protruding structures on the neck and the two animals fighting together. Here, one of the ideas was that they could have been actually a little sharp, so bloodied animals fighting it out in a deadly battle. I think this is my favorite example of how a conflict like this could have looked like. So, but it must have been quite a show. Now, there are other sauropods there. I will go through the rest of them a little faster. So, Mamenchisaurids, you might remember them. They aren't the biggest, but they have the longest necks related to the rest of their body. So here's one that lived in the Kimmer region also. So essentially the opposite of a Diplodocus. Instead of a very long tail, you have a very long neck. And when we talk about a very long neck, what is worth bringing up is how the hell did they breathe? This is a very long windpipe. Like, how deep of a gulp of air you need to take to actually be able to oxygenate your blood and your body, especially when it's so big. This is about 10 meters of air that needs to be pumped in case of brachiosaurids vertically, or in case of mamenchisaurids. And what needs to be known is that breathing in birds and their relatives was a little different. So they were actually able to maintain so-called continuous airflow. So while they were breathing in, their body was actually pumping the air out already. So even though, so they were essentially able to do two things at once in a very weird way. So this was actually a way more efficient system than what we do ourselves. So Sushi Commander asks, how did they keep balance? Usually it was done with the tail. So the tail was a counterbalance for the super long neck. Yeah, and here you can see the bones and where the piece of the bone where this trachea would have gone through. Now, there are more pieces of the sauropod tree that we need to cover, and this one is really interesting. So it is here also a diplodocid, but a different one from those. We'll be talking about this slice now. So going back to the one of the gents from the Bone Wars, this is Cope. And the piece of the bone you see here has been lost to science. It is... So, Luca, is that better? I'm trying to adjust the way you suggested. How does it sound now? Okay, let's keep going. So, Cope found this bone. He drew a scientific visualization of it, and then we lost this bone to never be found again. And there was lots of speculation what this bone actually was, because this vertebrae is fucking huge. And in fact, if you had a bone like this, and you were to reconstruct it as a Diplodocinae, so relative of Diplodocus, the animal would have been huge. This is Amphicoelia, so we are talking about an animal that is 60 meters long. And for the longest time, this is how some scientists believe it could have looked like. It was always a bit of a speculative animal. But because there was lots of egos at stake, Cope actually made a mistake. He classified this bone as a wrong group of animals. So Amphicoelias, as cool as it could have been, was not actually a diplodocid. It was a different diplodocid. So that third group that I told you, we'll be talking about right now. Oh yeah, sorry. This is actually a statue of Amphicoelias that you can find in Poland, in my home country. So if you ever decide to visit, you can go and see how Amphicoelias could have looked like next to human beings. So nowadays, scientists compared this bone to a different group of diplodocids. They are called the Rebbachisaurids. And what Rebbachisaurids are famous for is that they have this kind of hump, much taller back than other diplodocids do. And when you reconstruct this as a Rebbachisaurid, you get an animal that is a little smaller. You can see it here. So they actually took this drawing and reclassified it as Marapunisaurus. So about 30 meters long, much more pronounced back. Not many pieces of art of it. I wish there were more. And you can see it popping up in the family tree here. So that is the whole diplodocid family tree. You can see it on the top right here. Pretty big family tree. Rebbachisaurids are pretty interesting. They will actually get smaller over time, and they will turn into low browsing animals. So you can see the animal on the left. This is actually a Cretaceous animal. I won't be talking about it today. They will be adapted to eating low-lying vegetation. The other group of diplodocids that is a little unique are the Creosaurids. Again, this is a Cretaceous animal. They have relatively short necks, so there are sauropods with short necks, and they have those weird bones running alongside their body. And those most vanilla, like I suppose diplodocids, are here. So Diplodocidae, Apatosaurs and Diplodocinae. Now, looking at this family tree, you might notice one thing, which is that none of them actually make it to the end of the Cretaceous. All those groups of sauropod will become extinct before the asteroid hits. The group of sauropods that will go until the end of the Cretaceous will be here, but it is a bit too early to talk about them. So this one is a story for the Cretaceous. Just so you know, there will be someone to rise and take the place of all those other groups. But Jurassic is their heyday, and they are doing excellent in the Jurassic. Here are a few general pictures of how sauropods could have just looked like in the Jurassic. Here they are on the right. I just love this picture, this huge vegetation and massive forest with some sauropods walking through it. Here are a few of them walking through a mist with their heads in the low-lying clouds. So awesome, awesome, beautiful animals. And this one is maybe not as scientifically accurate, but I like that it shows the whole ecosystem with them in it. Now, this was about sauropods. Now, the second half of this presentation is about everything else. So first, we have Ceratosaurus. Ceratosaurus, not the biggest predator, but a little intimidating, if you ask me. It was actually present in Jurassic Park 3. I think very shortly it was hunting some humans, as theropods in Jurassic Park series tend to do. The characteristic is this horn at the top of its head. In the family tree of the theropods, it lies here. So it is a group that is kind of a genetically joint basal group to those other theropods. Here you can see what was likely a female and male, looking a little different, next to a human being. We don't actually know whether they would have used this in combat. And very cute picture. Oh, here it is. It was just hiding inside, scavenging on some massive sauropod. This probably isn't accurate. I just thought this is a very cool picture. It shows some of them hunting in a pack. This probably didn't happen, not for an animal of this size. And I think my favorite picture of the Ceratosaurus, this is a juvenile wading through a river, and a different take on the same scene. Really cute. Now, let's talk about some other neotheropods. We'll go to this part of the family tree now. So those are Coelurosaurs, so common ancestors of tyrannosaurids and other predatory theropods. They are very basic animals. I won't be talking about them too long. Just so you know, we have those basal forms here in the late Jurassic also. I really like this one because it might have had whiskers. There were those weird structures and in the fossils. And some small theropods just chilling there. There were some others, roughly, usually kind of middle-sized animals. Now, let's talk about something bigger. Let's talk about tyrannosauroids. Those of you who were here last time know I talked about the first group, Proceratosauridae. So those are the close relatives of true tyrannosaurs, but that are much smaller. They have this weird crest on the top of their nose. The ones that will actually lead to true tyrannosaurs are here, Pantyrannosauria, and they appear in the Khmer region. So first of them is Aviatyrannis, not very big, as you can see, a bit bigger than a cat. So tyrannosaurs still have a long way to go until we get to the true full-size Tyrannosaurus rex. Size-wise, pretty small. There are others like Uravenator, or Juravenator, I'm not sure how to pronounce it. This one is actually anatomically closer to a T-Rex, but size-wise, it is the smallest Pantyrannosaurus we know of. So Uravenator is on the direct line to Tyrannosaurus rex, but as you can see, size wasn't necessarily their priority back then. Here it is, just chilling in the undergrowth of a Jurassic jungle here on the coast, just waiting for other dinosaurs to finish eating a dead Ichthyosaurus to go and get a bite also. There were, of course, Allosaurids also, so the relatives of Allosaurus, like the Marsosaurus. Again, not a very big animal. You can see it here, but for us it wouldn't have mattered. It would have been easily able to get a chunk of us. Now, Megalosaurs, those were the ones that I call vanilla theropods. They don't have any really super unique structures on their bodies, They are just what you get when you think about just a predatory dinosaur. And Torvosaurus is actually one of the last of them. They will go extinct at the end of the Jurassic. And Torvosaurus is actually one of the biggest also. You can see here the theropods are growing in size just as the sauropods are. Size-wise, here is a comparison to T-Rex, which would come much later, of course. T-Rex is a Cretaceous animal. You can see Torvosaurus is starting to get within those body size, body dimensions that the T-Rex would also. And here are a few extra pictures of the animal. I think this one is my favorite. It shows it clearly side to side with a human being. All right, let's talk about stegosaurs. So stegosaurs emerged in the previous episode, and we have more of them here. Tuajangosaurus is probably one of the better known. Not huge, not as big as Stegosaurus. We are still a little bit away from the Stegosaurus, but they are starting to grow. And here you can see one fighting a Allosaurid of some kind. This isn't a true Allosaurid yet. Kentrosaurus is, I would argue, probably one of the most famous ones. If people know any other stegosaur aside from Stegosaurus, is probably this. It's probably the spikiest of them all. As you can see, there are less plates here, more spikes. We have those shoulder spikes also. So even though it's not very big, those spikes would have been quite intimidating. And two more pictures of it. You can see one on the right chilling on top of a fallen tree. I don't actually know if they would have been able to climb a tree like that. This might be just purely speculative. We also have Hesperosaurus. And Hesperosaurus, in terms of lineage, is very close to Stegosaurus. It looks very closely to what a Stegosaurus would have looked like, but it's a little smaller. So you can see it here next to a person. We have basically the Stegosaurus body plan, but it is not quite there yet. So to talk in depth about Stegosaurus, you will need to wait until the next stream. Here you can see one protecting its baby from a theropod trying to ambush it from the side. And of course, a very scientifically accurate representation of a Hesperosaurus also. And what isn't maybe the best picture, but I just like how they are a part of the environment here, and shown as not just those titanic animals towering over everything else. And I promised you dinosaur taxi, I believe, last time. So here is one visualization, some basal-ornithischian dinosaurs, so two-legged herbivorous dinosaurs. Just an idea some artist had, using those plates as a shade from oppressive sun and just hitching a ride on a Hesperosaurus. Speaking of those small herbivorous dinosaurs, here we have Nanosaurus. You saw this picture previously. Here is the one that we'll be talking about now. Those are smaller animals, filling the niche of more ground level herbivores. Now, let's talk about ornithischians in a little more detail. We talked about Stegosaurus, we talked about Nanosaurus, which is actually somewhere here. Stegosaurus are here. Let's talk about some others. Now we are going to talk about those ones, the Ornithopoda. Ornithopoda are the ancestors of the duck-billed dinosaurs. So Hadrosaurus, Parasaurolophus, Iguanodon, this is where their lineage has started. Those are the very earliest ones. You can see this duck bill slowly starting to merge on this animal, Diceratosaurus. They are still pretty small at this time in the Jurassic. And the one that is, I would argue, semi-famous, you can actually have this animal in the game Jurassic World Evolution, Dryosaurus. It is pretty cute there. It is a little larger, but again, not a very big animal. It is actually pretty well represented in the what is essentially fan art for the Isle. Some fan tried to reconstruct it, how it could have looked like if it was presented in the Isle, but I don't know if they actually plan to add it to the game. Size-wise, I think skeletons are always best to show how big of an animal it could have been, so you can see it on the left here. And some additional pictures with the eggs, with the young, just chilling, running through the undergrowth. Now, there was a bigger dark-billed dinosaur. Uh, which streamer? Platypus Origins? Not so, I'm afraid. But we might talk about the platypus relatives next time. So Camptosaurus was a little bigger. What you see on the right here is actually a comparison of various dark-billed dinosaurs. So Camptosaurus is the one in the blue, and the ones in the green and gray, the biggest ones, are actually late Cretaceous dinosaurs. So you can see here a comparison how much growing those animals too have left to do. Here it is just chilling. On the right, I think it is stripped. I am not actually entirely certain, but I thought it was a fairly cute picture. A 3D render. And now we move on to different group of ornithischians. This is still Ornithischia, and animals that are actually fairly close relatives of stegosaurs, the Ankylosauria. I promise you we would get properly armored dinosaurs in this episode, and this is it. Maemura pelta is the earliest ankylosaurid that we know of. As you can see, there is no mace at the end of the tail, which is something that we probably know those animals best for. But we have this armor, we have the spikes. Maemura pelta lies here in the Ankylosauria. And what I need to point out now is ankylosaurs are actually two groups of animals. First one that emerged are nodosaurids. Nodosaurids don't have tail clubs. They will never have them. What they will have instead will be really massive shoulder spikes. You will start seeing them a little later. And the other group, it won't actually appear in the Jurassic, we'll need to wait until Cretaceous, are the true ankylosaurs, Ankylosauridae. And the Ankylosauridae will get the mace, and they will have smaller shoulder spikes, but they will get this mace actually pretty late in the late Cretaceous. So most ankylosaurs actually did not have the tail club. Dark Lord asks if they could shed or regrow their armor plates. I'm actually not sure. I think those... I would guess not, because unlike nails, those wasn't keratin that they had. The structures you see here are called osteoderms, which are bony, not keratinous structures. And bone doesn't regrow, unlike nails. So I imagine my educated guess would be probably no. They probably wouldn't be able to regrow those things, but just like bones, they would have grown with them as they got older. Now, size-wise, early ankylosaurs aren't very big. This armor is a pretty good defensive measure anyway, however. Here is a skeleton of Maemura pelta. And here is another ankylosaur, also present in the Kimmer region, Gargoyleosaurus. Pretty interesting name. And actually what I managed to find on the right is an animation of how this animal could have moved like. Now, we are going to move to a different group of animals. We are going back to predatory animals. I'm going to start with Ornitholestes. I will tell you what it is in a moment. You have this smaller sized predator. You saw it in this picture previously. It is here on the left, stalking a Brontosaurus. Not the wisest thing it could do. And it was also present in this picture. So a fairly small animal. It lies in the Maniraptoriforms. Maniraptoriforms are relatives of Tyrannosaurs, but are actually a much bigger family tree. So you can see Ornitholestes is one of the basal Maniraptoriforms. So this group of Maniraptoriforms that almost all the other ones have emerged from. Now, the group of Maniraptoriforms I want to talk about is marked here in the red. You can see it's a sister group to the Aviales. Aviales are the ones where the true birds will be, but it is a pretty big tree on its own. And I think you know where this tree will lead, the closest relatives of birds. But what we will start with is actually this branch. So those are Troodontidae. And Troodontids are pretty small animals. What you can see here is this sickle claw at its feet. This is not a raptor, just FYI, nor is it an ancestor of raptors. It is just a very similar adaptation. Troodontids are closely related to birds and are fairly small animals, probably maybe not true flight capabilities, but some very basic gliding capacity. We don't know that for sure. They might have been decent at climbing some surfaces. What is interesting about troodontids is that they are also hailed as the smartest dinosaurs. I won't be talking about dinosaur intelligence today. We'll do that in 2 weeks, but keep it in mind. We'll go back to talking about them when we discuss dinosaur intellect. Now, you might notice that troodontids lay in a family of dinosaurs called Deinonychosauria. And you probably heard about Deinonychus. Deinonychus is this massive raptor. It's actually what was the inspiration for velociraptors in the Jurassic Park series. So the question you probably have, if we have Deinonychosaurs and troodontids in the Jurassics, do we have raptors also, right? So the proper name for a raptor is just a common word that pop culture has popularized. The proper word is dromaeosaurid. So dromaeosaurids, were they in the Jurassic? Let's discuss this now. And the only actual evidence of what could or could not have been a dromaeosaur are teeth. The problem with those teeth is, yes, we could probably attribute them to a dromaeosaur because we know how their teeth looked like. But this early in their evolutionary history, this close to the base of the tree, when you still have basal Deinonychosaurs, very basic troodontids, and potentially very early dromaeosaurids, we can't really be sure. Are there dromaeosaurid teeth, or are they basal Deinonychosaur teeth? Because if they are Deinonychosaur, then we don't have actual raptors or dromaeosaurs in the Jurassic, right? So to answer the question, were there true raptors in the Jurassic? The answer is, I do not know. We just don't know. We didn't find a full skeleton of a raptor living in the Jurassic, and the earliest stage and history of their evolution is an unknown, and we are waiting to find more bones. We are pretty certain we have basal Deinonychosaurs and troodontids, but raptors, that will remain to be seen. Now, we talked a lot about what was on the ground. Let's talk what was in the ocean. So, first, we'll start with the biggest oyster ever. This is Inoceramus, and for the record, the species Inoceramus was very abundant in the whole of Jurassic. And the reason why I'm talking about it now and not earlier is because this fossil, I believe, is dated to the Kimmeridgian period. So this is when it was found. As you can see, pretty big. I know you probably don't need additional size comparison, but here it is anyway. And the best art I found of it is this. There is no better art for Inoceramus, which I think personally is a crime against humanity because it is pretty freaking awesome. We had some other stuff swimming in the Kimmeridgian seas and oceans. So you remember pliosaurids, those short-necked marine reptiles, and they are starting to get big. The marine reptiles weren't very big so far, but now their size is starting to explode. So Megalonychosaurus is about this big next to a person here, but there is a bigger pliosaurid here, and in fact it is the pliosaurid after which all pliosaurids are named. So this is a Pliosaurus. And now, first I want to show you this picture. This is very conservative in terms of size, so you can see about 10 meters long for the largest, but there is actually a different estimate. Later, when we get to the final stage of the Jurassic, I will show you some fossils of a species or just an animal that might be the same species actually, that could have grown to as much as 30 meters long. So a very big animal. Pliosaurs in the Kimmeridgian, however, are probably closer to 10 than 13 meters. That Predator X that you see here is actually the animal after which the Leupleurodon was first confused with. So last time where we talked about Leopleurodon in Walking with Dinosaurs, it was shown as this huge animal, while Leopleurodon was actually just a few meters long. What they actually meant when they showed that animal was Predator X, so Pliosaurus funki. And Pliosaurus funki will live at the end of the Jurassic. We'll talk about it in more detail in 2 weeks. Here are some additional pictures of the Pliosaurus. Here it is next to a human being, so you can see we are getting into the area of really big animals. And here it is hunting some small Plesiosaurus, sorry. Some cool art of the animal to go through. And of course, we also have Plesiosauroids, but just FYI, end of the Jurassic has a very poor record of marine fossils. It's great for terrestrial life, but very bad for marine, so we don't know that much. Jupedalia was one of the Plesiosauroids living at this point, getting a bit bigger also. Usually, so far, we had them about 3 to 5 meters. This one is 6 meters long. We also have Spitrasaurus. The fossil record is so poor that we don't get much art of it, so we are going to use this plushie. Spitrasaurus was found with only those bones, so very few of them, and reconstructing them could be a little difficult. It's named Spitrasaurus after Spitsbergen, because that's where it was found. There are ichthyosaurs there also. I apologize, I'm getting a ping. I just need to check something very quickly. Yes, those are technically work hours. So Brachypterygius is an ichthyosaur. We still have them here. They aren't a dominant form of life in the oceans. That's a niche that those pliosaur and plesiosauroids have taken. Although, pretty sizable animal on its own. And one more picture of it. Pretty cute. Dolphin-like colors, purely speculative, just FYI. This is a reptile, just so we are clear. And we have Thalattosuchians. So Thalattosuchians are relatives of crocodiles, not true crocodiles, and they are not going to be the ancestors of crocodiles. They are a sister clade. Length about 3 meters. I know, very accurate scale here, but I was in a hurry. And one of the more interesting Thalattosuchians is Dacosaurus. This is also a crocodile relative, but with a short snout. I think it looks a little bit like something out of a nightmare. You see flippers instead of legs. You see the split tail. So even though it's a crocodile relative, it starts to look very differently. You can see a few pictures of it here. Not the biggest predator in the seas, but pretty intimidating. And here's one that I think is just a super interesting piece of art. After it's been beached on the surface, I just love those barnacles on its skin. And some, of course, very accurate depictions of it additionally. But cute pictures aside, this is probably how it looked like. So for us, it would have been truly a mortal danger. Now, I want to bring up Abzu, which is a video game you might have heard about, because Dacosaurus is actually present in the game. Short spoiler alert, but it's been years since the game released. There is an area in the game where you can swim with lots of different prehistoric animals. I really recommend it. There are lots of them, some of them pretty unique and a little bit obscure. Abzu is just a few dollars. So if you want to check it, go ahead, you have my blessing. Now, let's talk about other crocodilomorphs. That is Machimosaurus. And this is where things start getting a little bigger. So, in all fairness, there is a little bit of experimentation with perspective here. The animal itself was about this big, still pretty intimidating. This is also a Thalattosuchian, but a semi-aquatic. So not flippers, but legs in this case. Here you can see on the left, one running away with a dinosaur leg, and the one on the right hunting a shark. Here is a few of them living in the river estuary, just chilling in the sun. Size-wise, this is probably a more accurate representation. There is a model next to a human being. This is the largest crocodiliomorph living in the Jurassic. The true crocodiles, however, or rather the ancestors of true crocodiles, so-called Neosuchia, are a little smaller. You can see a human hand here next to one. Theriosuchus is a small animal. It is actually a galloping crocodile. Sorry, crocodilomorph, not a true crocodile. Here it is eating a snail, which is what its prey would have been like back in the day. This is a different one. I won't try to pronounce its name. I apologize. Here it is facing off around a lobster against a lobster. We also have turtles. We have snakes. These are some of our earliest snakes in the Jurassic. You can see here they still have legs. So Portugalophis is one. Here are the legs. Diablophis is another. It's going to take a while for the snakes to actually lose their legs entirely. We also have mammals like the Teutonodon here. Lots of others here. Morrison's formation actually gave us lots of mammal fossils. Docodon here is about the size of a cat. As you can see a close-up here, very accurate running animation on the top right. And even though it's getting a bit bigger, so it's not mouse-sized but cat-sized, it is still prey for dinosaurs. Most of them are actually pretty small, like the Fruitafossor here. You can see smaller than the human foot. And today we'll end with pterosaurs. So Cuspicephalus is one of those with still long tails. I told you that last time that those are actually in decline. What will be taking over are the pterosaurs with no tails but much bigger heads. You can see a size comparison next to a robin here. And some additional art of it. I love how big this crest is, and believe me, some pterosaurs will have much bigger crests than this. Again, we have some of those smaller pterosaurs, well, not smaller at this point, but pterosaurs with long tails and smaller heads, but they are getting bigger also. So at this point, the pterosaurs have started growing properly. Harpactognathus was actually featured in the Ice Age. In part 3, I believe, is when they encountered dinosaurs. So you could see it in the movie. Not the most accurate reconstruction, I'm afraid. We have Rhamphorhynchus, again one of those last smaller body long-tailed pterosaurs. Here it is hunting for a fish in the water. And this is actually very interesting because this is a fossil of this fish on the right after it has caught Rhamphorhynchus, and they both got buried under mud, underwater. Of course, very accurate depiction of the animal here. And it in flight over a forest. Now, most pterosaurs at this point are so-called pterodactyloids. So again, just to remind, big head, short tails, or no tails at all. Germanodactylus is one of them. This is a small one, but we have big ones also. Like Cephodactylus is, I think, the largest pterodactyl living in the late Jurassic. Just FYI, even though it's big, it was super light because its bones were hollow, so it wouldn't have been actually able to pick up a human being and fly away with it. Some of them are smaller, some of them are bigger, so the size there is a lot of variation here. And of course, my favorite pterosaurs, so-called Anurognathids, are present here also. So those pterosaurs don't have beaks, they have those wide mouths used probably to catch insects in flight. Mesadactylus is one of them. Size-wise, pretty small animal. You can see a flock of them here escaping a tree after a Camarasaurus tried to get a scratch and actually collapsed it. And a few of them just chilling, perching among the plates of a Stegosaurus. FYI, no Stegosaurus in the Kimmer region. There will be a Stegosaurus at the end of the Jurassic. This is just going forward a little bit. And one last pterosaur that I want to show you with a very interesting crest, Normanognathus. Not the biggest one of the small ones. This crest is actually fairly speculative. It also could have been pretty big like this. We don't know for sure how it looked like. Now, wrapping up Kimmer region, what I want you to remember is even though there is lots of variety in this time period, it is really the heyday of the sauropods. So all those diplodocids, brachiosaurs, other stuff you saw earlier, this is when they were the most diverse, the most groups of sauropods lived. There will be most of them getting unto the end of the Jurassic, but they will start declining. So this will be it for today. I hope you enjoyed the journey into the Kimmer region. This was just 5 million years of prehistory, but this was quite a busy time time period in the Jurassic. We have one last part of the Jurassic to go through. I'm calling it the boundary because we will be going until the very edge of the Jurassic and even veering a little bit into the Cretaceous. And next week we'll be talking about a very famous aviale dinosaur, Archaeopteryx. We'll be talking about how smart were the dinosaurs, Stegosaurus and those Troodontids, which are claimed to be the smartest. We'll be talking about some different weird aquatic reptiles that were very long. Zombie ammonites, Compsognathus, which you probably heard about, will be a part of the presentation. The Pterodactylus will be a part of the talk, so the one that all the pterodactyls were named after. I will show you some graphic imagery of an Allosaurus nutshot. Yes, this is not a clickbait. There will be some cute stuff too, so baby dinosaurs, and we'll talk about camouflage, Jurassic butterflies, and we'll close at the very end of the Jurassic and the border with the Cretaceous. So, this is it for today. Thank you for attending, everyone. It's always great to see that people are coming back to watch those. Next one is in 2 weeks. If you have any questions and don't need to run right now, feel free to ask them right now. Other than that, I will be wrapping up. So, which streamer? How accurate are the colors of dinosaurs, and how would they have speculated on them? So, nowadays, we are actually able to reconstruct some dinosaur colors. There is a field of science for this. Some paleontologists say this is very close to divining from a crystal ball, but there are actually some fossils which are preserved well enough for us to determine the color of the animal. The process, I don't want to get into it today because there will be a better time for it, but the process is quite destructive to the fossil, however, so not many museums are actually willing to give up their fossils to undergo this process and discover what color they were. But when it comes to speculating on dinosaur colors, you can make assumptions based on their role in the food chain and their environment. So if they were ambush predator, they probably would have had the kind of coloration that would have helped with that. If they were a smaller herbivorous dinosaur living in a forest, they would have had the colors that would have helped them hide them. So there is a bit of deduction and detective work to do with it, but we are capable of actually reconstructing accurately the colors of some dinos at this point, but I won't be talking about this today. Iseluka, how long would they live? I'm actually not sure. I didn't do research in the lifespan of sauropods. What is worth mentioning is that it would have been a decently lengthy life because they would have been growing all this time, even though sauropods were growing very fast because they were. It would probably take them at least a few decades to get to their maximum body size. Corpse prints. Wouldn't evolutionary divergence lead to a lot of different colors regardless of behavior? I mean, yes, there is always a chance of mutation. We see this nowadays also. Like we get albinos, we get rare lions. The question is, those colorations always get suppressed a little bit. Like the color is also a tool. So colors need actually to be useful for something. Some animals, of course, select for coloration differently. There is sexual dimorphism. Some of them use colors to attract mates or for species identification. So yes, there is room for asking questions like that and wondering whether the colors that make sense would actually have been the one that the animals would go for, or would they actually be more colorful because there is a sort of societal layer to their species that we need to take into account. And yeah, it was my pleasure with streamer. So I'm not seeing any more questions at this point. I imagine everyone is anxious to run back to their work, and I have to do also. So thank you again, everyone, for tuning in. I hope you have enjoyed yourself and that you would join me for the final part of the Jurassic series in 2 weeks, and that I will see you there. So take care and enjoy the rest of your day.